Are you confused about how to secure and structure a manufacturing plant's network? Ever heard of the Purdue model but not sure how it works? In this video, we're going to break down the Purdue Enterprise Reference Architecture, the foundation for secure OT networks used in factories, power plants, and industrial systems worldwide. Let's dive in. Originated in the 1990s by Purdue University, defines 5 hierarchical levels, or zones, to organize and isolate industrial network functions, used as a standard in ICS/SCADA and OT cybersecurity frameworks like IEC 62443. Level 0 Physical Process. Explained simply, Level 0 in an industrial automation system is the very foundation where the actual, physical work happens on the factory floor. It includes the devices that directly interact with the machines and processes used in manufacturing. These are things like sensors, which measure real-world conditions such as temperature, pressure, or position, and actuators, which perform actions like turning motors, opening valves, or activating welding arms. For example, in a car manufacturing plant, sensors detect if a car door is in place, and actuators move robotic arms to weld or paint it. These devices are connected to controllers, like PLCs at level 1, using digital or analog input/output signals or Fieldbus communication protocols such as Profibus, Modbus, or EtherCAT. The key feature of Level 0 is that it deals with real-time signals, meaning the information must be processed and acted upon instantly to keep production safe and efficient. This level is critical because it forms the link between the digital control system and the physical machines that make products. Without a reliable Level 0, no automation system can function properly. It's where automation touches the real world. Level 1 Basic Control Layer is the part of an industrial automation system where the actual control and decision-making for machines and processes happen. Think of it as the nerve center for each production cell or machine. This layer includes devices like programmable logic controllers, PLCs, robot controllers, and distributed control system, DCS, controllers. These are smart devices programmed to automatically manage the operation of machines. Their job is to constantly monitor inputs from Level 0 devices, such as sensors that detect temperature, pressure, or position, and based on that information, send precise commands to actuators, like motors, valves, or robotic arms, to perform tasks such as moving parts, starting pumps, or executing welding operations. For instance, in an automotive plant, when a car body reaches a welding station, the PLC, or robot controller at Level 1 takes over, triggering the correct welding tools in a carefully timed sequence to ensure proper joint strength and safety. These controllers run on specialized real-time operating systems, RTOS, designed by manufacturers like Siemens or Rockwell, which allow them to process data and respond in milliseconds. Communication between these controllers and field devices happens using industrial communication protocols such as Profinet, EtherCAT, Modbus, or DevSenet, which are optimized for fast, reliable, and deterministic, timing-guaranteed data exchange. Level 1 control systems are typically confined to individual machines or production cells, where high-speed and high-precision operations are required. Their proper functioning is essential to ensure that every part of the process works as expected, efficiently, safely, and in sync with the larger automation system. Understanding Level 2 Area Supervisory Control in Industrial Automation. Level 2 Area Supervisory Control is the layer in an industrial automation system where human operators and engineers interact with machines through screens and software. It acts like the control tower for a section of the plant, overseeing and managing several machines or processes at once. This level includes devices like human-machine interfaces, HMIs, SCADA, supervisory control and data acquisition systems, and control room workstations. These tools display live data coming from Level 1 controllers, like PLCs, and let operators monitor operations, send commands, such as start/stop, and respond to alarms. For example, in a car manufacturing line, an HMI might show if a welding robot is running correctly, and the operator can pause it if a problem occurs. Level 2 also often collects and stores data using software called data historians, which record things like production rates or temperature trends for future analysis. Communication between Level 2 systems and Level 1 controllers uses industrial protocols such as OPC-UA, a widely used platform-independent standard for data exchange, or vendor-specific ones like Siemens S7 or Rockwell CIP. Typically, Level 1 and Level 2 devices in the same production area are grouped in what's called a cell/area zone, sharing the same network to enable fast and reliable control. This setup is crucial for real-time supervision and efficient operation of the plant. Understanding Level 3 Site Operations/Manufacturing Operations Systems, MOS, in simple terms. Level 3 in an industrial automation system acts like the central brain of the entire factory. It's where big-picture decisions are made to ensure the whole production line runs smoothly, efficiently, and according to schedule. This level doesn't directly control machines but manages, monitors, and optimizes operations across various sections of the plant. At the heart of Level 3 is the Manufacturing Execution System, MES. Imagine MES as a smart manager that tracks everything happening on the factory floor: what products are being made, how many are done, what's still in progress, and whether everything meets quality standards. For example, in a car manufacturing plant, MES will keep track of how many car doors have been assembled, whether any units failed quality checks, and what tasks are next. Level 3 also includes SCADA servers, which provide a bigger overview of plant operations, and batch management systems, which are used in industries like food, chemicals, or pharmaceuticals to manage recipes and production steps. It may also include data historians software that stores long-term information about processes like temperatures, pressures, or production counts so engineers can look back and find patterns or problems. Technically, Level 3 connects to all the lower levels, like machine controllers in Level 1 and operator systems in Level 2, through a high-speed industrial Ethernet network. It communicates downward to control systems and upward to enterprise-level systems, like ERP software, that handle business decisions. Because of this dual role, Level 3 is a critical security layer. It often connects to a DMZ, demilitarized zone, to safely bridge the operational network with corporate IT. In addition, this level may also house engineering workstations where technicians create or update programs for PLCs, and patch management servers that ensure industrial devices receive necessary updates without affecting production. Overall, Level 3 makes sure the factory runs like a well-oiled machine from the top-level business goals down to the nuts and bolts of production. Understanding Level 3.5 Industrial Demilitarized Zone, DMZ, in simple terms. In today's modern industrial networks, Level 3.5, also known as the Industrial Demilitarized Zone, DMZ, plays a crucial security role even though it wasn't part of the original Purdue model. Think of it as a guarded bridge between two very different worlds, the factory floor, OT operational technology, and the office world, IT information technology. The DMZ acts as a protective buffer to prevent direct communication between these two layers, which could open the door to cyber threats. Instead, all data sharing or remote access between the OT and IT must go through this controlled zone. Inside the DMZ, you'll typically find special servers like a copy of the plant's historian system, which stores production data, jump servers for secure remote access, and update servers that safely bring patches or antivirus updates from IT to OT. Sometimes, even parts of the manufacturing execution system, MES, are placed here to ensure secure communication. The entire DMZ is tightly monitored and shielded by firewalls on both sides, following international cybersecurity guidelines like IEC 62443. This setup ensures that any traffic between business systems and plant systems is inspected, logged, and secured, keeping critical operations safe from cyber attacks while still enabling business needs. Understanding Level 4 Enterprise Network in simple terms. Level 4 in an industrial automation system is the enterprise or office network. Basically, the part of a company's digital world that employees use for everyday business tasks. This includes things like office internet, email, company websites, business software, like SAP or Oracle, and data storage systems. It's where you'll find systems like ERP, Enterprise Resource Planning, which track things like inventory, customer orders, finance, and more. Although this layer doesn't directly control machines or handle production, it still plays a big role. For instance, an ERP system may need to know how many products were made today or send a request to start a new production batch. To do this safely, data has to pass through a secure middle zone called the DMZ, Demilitarized Zone, which acts like a checkpoint between the business world, IT, and the factory floor, OT. This helps prevent cyber threats from traveling down into critical manufacturing systems. Level 4 networks are run by the corporate IT team and use standard security tools like firewalls, antivirus, and intrusion detection systems. One of the most important safety rules in a modern factory, organizing the network into different layers like stacking floors in a building makes it much easier to protect the system and manage how data flows. Each layer has a specific job. The lower layers, levels 0 to 2, are where the actual machines and control systems live, working in real time to make things like cars or bottles. These are placed in small, isolated zones to ensure fast and safe operation. The higher layers, levels 3 and 4, are more about managing the whole process, tracking what's being made, planning the next steps, or handling business tasks like inventory or finance. This layered structure helps create security rules. For example, a machine controller, level 1, should never be connected directly to an office computer, level 4, because that could let a virus or hacker move from the business network into critical factory equipment. Instead, any necessary communication, like when a business system needs production data, must go through a carefully controlled path passing securely from the PLC, level 1, to SCADA, level 2, through the DMZ, a protected buffer zone, and finally to the enterprise network, level 4. At each step, security checks are in place, creating strong protection using a method called defense in depth.